I'm about to teach you almost all of Python syntax. You'll learn about the things that Python can do. We'll be going quick, so it may be helpful if you have at least some programming experience. In this tutorial, if I show code that starts with 3 angle brackets, that means it is the Python shell. The lines of code are run individually, and the result of running the code is displayed right below. If there are no angle brackets, that means it's a section of code that's meant to run all at once in a program. Okay, let's get started. Basic math works just like you would expect in Python. You can just do addition, multiplication, division, basic order of operations. You can use parentheses. You can concatenate strings just by putting 2 strings right next to each other. You can use a plus sign to concatenate them, to put them together, but you don't have to. You can just use a space. And you can also multiply strings. Alice times 5 equals Alice 5 times. This is how you create a variable. Spam is the variable name, and it's set to equal the string hello. And this is a comment, and then a multi-line comment. And this is how you initialize a variable. We're initializing the a to 1. And you can print a message to the console, just like this, print hello world. And in the print statement, you can put a comma, and we have a string and then the variable, and it just puts a space in between. Now here, this is how you get input from the user, just this input here. We can set it to this variable, and then we can print what was typed in. And this is a special way, this dot format is a special way to put a variable in a string. There's a few other ways that we'll talk about later. The length function, we can get the length of a string, hello is 5 characters, and the str will convert an integer into a string. And then int, we can convert a float into an integer. These are the different equality operators. It's pretty much the same in every programming language. Just keep in mind that equal to is 2 equal signs. A single equal sign is the assignment operator. So we can check to see if hello equals hello. Well, no, because there's a capital letter in one and a lowercase h in the other. An int and a float do equal each other. An int is a number without a decimal, and then a float is a number with a decimal point here. And we can also see if something is not equal. Dog does not equal cat. That's true. But you should never use the equals or not equal operator to evaluate Boolean operations. Use the is or is not operators, or use implicit Boolean evaluation. We can use and to evaluate 2 things, so the first one and the second one has to be true for this to evaluate it as true. And we can use or, so either this part or this part can evaluate as true for it to be true. And you can combine multiple ands and nots together. And this is how you do an if statement. So if the name equals Alice, then we'll print hi Alice. And in Python, spacing or tab is very important. After the colon, the next line has to be indented or tabbed over, and each line that's indented the same amount will be inside the if statement. So here's how you do if else. So if the name is Alice, print hi Alice, else if any other condition, if name equals anything else, print hello stranger. We can also do an elif or an else if. So if this is true, then we do this, but else if, we're now going to check if this is true. If age is less than 12, then we're going to print this. And if neither is true, we're not going to do anything. Now we have the if, the elif, and the else. We've combined everything. So if the first 2 are not true, we'll do this last line here. And this is a loop. This is a while loop. So while spam is less than 5, it's going to keep running these lines of code over and over until spam is not less than 5, and then the code will stop running. Now if you do while true, that means it's going to continue doing this forever. But if it hits a break statement, then it's going to break out of the loop and then go to the line underneath the loop. The indentation shows which lines of code are within the loop. So these 3 lines are all indented, so they're all in the while loop, and then this line is indented even more, so it's in the if statement. So here's another while loop. If we get to continue, that means we'll just go to the next iteration of the loop, and it's not going to run any of the code after the continue statement. So if name does not equal Joe, it's just going to now get another input from the user. And then when it gets to break, that's when it will break out of the loop and go to this next line of access granted. Here's another type of loop, a for loop, for I in range 5. So range 5 is going to go through the loop 5 times, and I is going to be each number in the range from 0, 1, 2, 3, 4. So you can see it prints 0, 1, 2, 3, 4. It gets used the format to add this variable right into here, into the string. Another way you can create a loop is with this. So range 0, 10, 2. So 0 is the first number in the range, 10 is the last number in the range, and 2 is the increment. So it's not just going to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to do 0, 2, 4, 6, 8, which you can see down in the print statement. And you can also count backwards. So now we're incrementing by -1 each time. So here is a for else statement. The else statement will only run if a break has been reached in the loop. And here's how to import a module. We're importing the random module, and then we're using the random module to get a random integer between 1 and 10. And this is how you would import everything from the random module. If you want to end a program early, you can use sys.exit. This is how you create a function, def hello, and then you can pass in a name to the function. And then this is what is the body of the function. So we can call this function many times. So here we're calling the function hello and passing in Alice. And you can see it prints hello Alice. That's right here, hello Alice. It's getting the Alice from this name variable here. And we can also call the function again, hello Bob. So you can call the function multiple times with different things that we're passing into it. And here's a function with return values. So when this function is run, this getAnswer function is run, it's going to return something different. See, return it is certain, return it is decidedly so. So depending on what answer number it is, it's going to return a different text. So we're going to get a random integer here, and then we're going to get the answer of the random integer, and it's going to print the fortune, which is going to be one of these strings. Normally a print statement will have a new line at the end, but if you specify end to be just an empty string here, there will not be a new line at the end, so then both print statements will happen on the same line like that. And this is just an example of printing a bunch of strings, and if there's a comma in between them, it's just going to put a space in between them when it prints out. And you can also specify what the separator is. Normally it's a space, but you can specify it to be a comma or anything else. Usually if you define a variable within a function, you cannot use that function outside of the variable. But if you put the global keyword here, global eggs, and we're setting this variable eggs to be a global variable, so now when the function runs here, it's actually going to change the value of the eggs variable. When it prints this eggs, it's spam. This is basic exception handling. You use the try except keywords. We're going to try something that could cause an error. Now, if you don't have in this try block here, an error will make the program end. But if you have this try except, instead of an error making the program end, it will do whatever happens here. Except if there's a zero division error, then it's going to print error invalid argument. And you can see in this example, when we print the spam 0, it's not going to make the program stop. It's going to print this error. Here's another example with a finally statement, a finally section. Code inside the finally section is always executed, no matter if an exception has been raised or not, and even if an exception is not caught. Here is how you create a list. A list in Python is similar to an array in some other programming languages. And a list is just a series of values. They could be strings, ints, or some other variable type. And here's how you access an element in a list. You count from the beginning, and you always count starting at 0. So when we do spam 0, that's going to be cat. If we said 1, that would be bat, 2 would be rat. And we can do a negative number to start counting from the end of the list. So -1 is going to be elephant. Here's how we get a sublist with slices. So we define the list here, and then spam 0:4 is going to be a section of the list starting at the 0 index and ending at the 4th index. In this case, it's actually the whole list again. But here, 1, 3, we're going to start at bat and then rat, or 0, -1. We start at cat, and we're going to end at rat because -1 will be elephant here. So you're going to go up until, but not to, the final number after the colon sign. If you slice the complete list like this, it's going to create a copy. So now we have the original list, spam and spam2. If we use .append to add an element to the original list now has dog, but the copy does not have dog at the end. And we can use the length function to get the length of the list. There's 3 items in that list. You can change values in a list with indexes. So spam index 1, we're now going to set that to equal aardvark. And if we look at the list again, now aardvark instead of bat is in index 1. And we can also set index 2 to be whatever's in index 1, and we can see it's cat, aardvark, aardvark, elephant. You can just use the plus operator to add 2 lists together to become 1 list. You can also multiply a list to multiply the list 3 times. And here's another example of using the plus operator to combine the list. And you can delete an element of the list with delete, or del, and then we're deleting the element at the index 2, which is rat. You can use for loops with lists. So for I supply and enumerate supplies. Using enumerate is going to make I the index, and supply is going to be each item in the list. So we print index in supplies is, and the format, so this is going to go into the first curly braces, and the supply is going to go into second curly braces. You can see how that works. And you can loop through multiple lists with zip. So we have zip here, so now we're going through the name and the age list into N and A, and you can see what that prints out. You can use the in and not in operator to see if something is in a list. So howdy in this list? Well, true. Is cat in spam? False. Howdy not in spam? False. This is the multiple assignment trick where you have this list that equals cat. Now if size, color, disposition equals cat, it's going to assign each element of the list to each of these variables. The multiple assignment trick can also be used to swap the values in two variables. You can use the plus equals operator to add something to a variable. Spam equals hello. This line right here, spam plus equals world, is the same as spam equals spam plus world. And as you can see what it equals here. You can also use it with the times equals operator. And we can use dot index to find out the index of a certain item in a list. And we already talked about this, but dot append can add an item to the end of a list. And insert can add an item at a specific index in a list. And dot remove will remove the first item in a list that has that value. And you can use dot sort to sort a list. You can sort number lists, you can sort string lists, which will store in alphabetical order, and you can also reverse the sort with reverse equals true. You can also use the built-in function sorted to return a new sorted list, sorted spam. Now we'll talk about the tuple data type. The main way that tuples are different from lists is that tuples, like strings, are immutable, so you cannot change them. So here is a tuple, which is kind of just like a list, and you can still access the items in the tuple similar to the list. So at index 0 is hello, and we can get the items from index 1 to 3, we can get the length, and this is showing that we can convert the types with the list and tuple functions. So we have this tuple function, and we pass in a list, and it returns a tuple. We have this list function, we pass in a tuple, and it returns a list. This is an example of a dictionary. A dictionary is similar to what is called an object in some other programming languages, and a dictionary is made up of key-value pairs. So the key is size, the value is fat. The key is color, the value is gray. The key is disposition, the value is loud. You can use the dot values to get each value. So in this for loop, we're looping through all the values, and we're printing the values, red 42. You can do the same thing with the keys. So dot keys, and now we're printing the keys. And then with dot items, we can print each item in the list that has the key and the value. And here we're storing the key and the value into these variables as we iterate over the dictionary. We can check whether a key or value exists in the dictionary with the in. So if name in spam.keys, true. Zoffy in spam.values, true. And you don't even have to do spam.keys. You can just do color in spam false. This get method has two parameters, the key and a default value if the key does not exist. So here it's trying to get the value of cups, which does happen to be 2, but if there is no cups, then it's going to return 0. Here in the second one, there is no egg, so it does return 0. If we look up at this top section, first we're checking if color is not already in the dictionary, and if so, we'll set it to black. Well, there's an easier way to do it, which with set default. So if you do spam.setDefault, color black, it will only add the color as black if color is not already in the dictionary. This is a way to merge two dictionaries. So we have the two dictionaries X and Y, and if we see what Z is with the asterisk asterisk X, asterisk asterisk Y, and now we've merged those two dictionaries into one. Here are two ways to create sets. A set is an unordered collection with no duplicate elements. You can use sets to test for membership and to eliminate duplicate entries, and they support mathematical operations like union, intersection, difference, and symmetric difference. So you see we're creating this set that does have 2 2s and 2 3s, but then when we check to see what S equals, there's only 1 2 and 1 3 because sets cannot have duplicate entries. And since they're unordered, you cannot access an index number because they're not stored in any particular order. You can add an element to a set with .add, and .update will add multiple elements to a set at once. And you can use .remove to remove an element. If you do .remove and remove an element that's not already in the set, you will get an error. .discard is just like remove, except when you try to discard something that's not in the set, there will not be an error. The .union method will create a new set that contains all the elements from the sets provided. The .intersection method will return a set containing only the elements that are common to all of them. The difference method will return only the elements that are unique to the first set. And the symmetric difference method will return all the elements that are not common between them. This is an example of a list comprehension. So we have this list, and then we're going to create a new list, but it's going to do something to each element in the original list. I minus 1 for I and A. So each element in the list we're going to subtract 1 from. And here's an example of set comprehension. So we have the set, and we're doing s.upper for S and B. So we're actually changing each of these elements in the set to uppercase. And then this is a dictionary comprehension, where we're going to do something for each element in the dictionary to create a new dictionary. These are examples of some common escape characters. If you want a string to contain a single quote, double quote, tab, new lines, or backslash, you're going to instead have to put this in there with these escape characters. So here's an example. If you put a /n in a string, when that prints out, it's going to put a new line. See where it says, I'm doing fine, you can do single quote to make it appear as a single quote. If you put the letter R at the beginning of a string, it becomes a raw string. A raw string completely ignores all escape characters and prints any backslash that appears in the string. You can use triple quotes to do multi-line strings. So the string starts with these 3 quotes and it ends with these 3 quotes down here. But with triple quotes, you can see everything starting at the very beginning of the line, so you can't indent it at all. But you can indent if you import the dedent function from the textwrap standard package. And then you can use the triple quotes and you can indent everything, and this code is going to generate the same string as before. This here, the Dear Alice letter here. Let's talk about indexing and slicing strings. Just like getting an element of a list, you can get a letter in a string. So you just count from 0 and you can get the letter 0, the letter index 0 of the string is H. You can also get sections of a string. You can slice a string 0 to 5 of the string, or if you just put blank :5, it's going to assume 0, or if you put a blank at the end, it's going to assume the last character in the string. And here's another example. You can use the in and not in operators with strings. So hello is in hello world, hello capital letters is not in hello world, and then cats is not in cats and dogs. Well, that's false because it actually is. You can also use the in and not in operators with lists. So 5 is in A, false. And we already touched on this a bit, but you can use .upper to change a string to uppercase, or .lower to change a string to lowercase. And you can use .isLower to find out if a string is all lowercase. In this case, it's false because it has this uppercase letter. We can use isUpper to find out if it's all uppercase, which is false. But here, hello is upper, true, that is all uppercase. And you can do .starts with to see if a string starts with certain letters, or .ends with to see if a string ends with certain letters. You can use .join. You take a string and do .join, and then you pass in a list, and now we'll change that list to a string, joining the elements with whatever string it starts with here. So here, we use the comma. You can also use a space here. And you can split a string with .split. Splits into a list. And normally it's just going to split at the spaces, but you can split at anything, like you could split at ABC. .rjust will write adjust, and the full string is now going to be 10 characters, and the hello is going to be write adjusted to the end of the 10 characters. Or it can do with 20 characters. So this rjust right justifies. You can use ljust to left justify in the same way. And you don't even have to have it spaces. You can have asterisks or dashes or anything you like. And .center will center a string within a certain number of characters. You can remove white spaces with .strip, and it's going to strip off all the spaces at the beginning and the end. rstrip will just remove the spaces at the beginning. lstrip will remove the spaces at the end. We've already talked about .format. It's just a way to get variables into a string at where the curly braces are. F-strings are in some ways an even better way of putting variables into a string. You start the string with the letter F, and then you use curly braces, and you can put the variable right in here. So we're using the variable inside the string. In an F string, you can also do arithmetic, or put any code you like within the curly braces. So you can see with a plus b, 2 times a plus b, and it's right within those curly braces. You can raise your own exceptions or errors within a code. So raise exception, and then this is going to be the message that's going to print out. So you can see an example of what happens when that exception is raised. You'll commonly see a raise statement inside a function, and then the try and except statements in the code calling the function. So this box print is going to raise these exceptions, and when we call the box print function, it's in a try and except block. So it's going to try box print, and it may raise any of these exceptions. And if it does, it's going to print an exception happened, and then put the string of the error. Assertions are sanity checks to make sure your code isn't doing something obviously wrong. These sanity checks are performed by assert statements. If the sanity check fails, then an assertion error exception is raised. So here are some examples. We have this pod bay door status equals open, and we're going to assert that pod bay door status equals open. If this was false, this error would be displayed. So we're going to set pod bay door status to not be open, to something different, and we're going to assert that it's equal to open, but it's not equal to open. So you can see down here, the exception will happen. So this code is a little smaller, but it's an example of logging. To enable the logging module to display log messages on your screen as your program runs, we'll import logging and then configure logging. And then you can add this code within this function that's going to log certain things to the console. Now let's talk about lambda functions. If we look at this top part of code, this is a normal function. This function is called add. It takes 2 arguments, and it's going to return adding those things together. So add 5, 3, it's going to return 8. Well, this function down here is a lambda function, and it's equivalent to the function above. It's creating this function on a single line. So the add is now at the beginning, add equals lambda xy, and you can see the colon is going to add x and y together. You can even create a lambda function without a name. So before it was called add, but this isn't even called add. We just create the function, and then we pass in the numbers right at the end. Like regular nested functions, lambdas also work as lexical closures. So basically you can use a function to create another function. So now we're making a +3 function that's going to add 3 to numbers, and a +5 function that's going to add 5 to numbers. So +3, 4 is going to add 3, +5, 4 is going to add 5. This is how you do ternary operation within Python. So this is basically a one-line code. So this is basically an if-else statement in a single line. So we're going to print kid if age is less than 18, else print adult. Now let's talk about args and kwargs. So you can see args here. The actual word args is arbitrary. The important thing is the asterisk, or if there's 2 asterisks. So the asterisk basically means pack all the remaining positional arguments into a tuple, while 2 asterisks is the same for keyword arguments. So basically what that means is that we can pass in as many arguments as we like. So fruit, this can be 1 argument, 2 arguments, 3 arguments. In this example, we're passing in 3 arguments, and that's just going to print each one, but you could have had 4, 5, 6. So that's what the asterisk does. The kwargs, it means keyword arguments, and you can have an indefinite number of them, which is just key value pairs. So we can pass in an unlimited number of key value pairs, and here's just going to print them. This here is a special way to only run code if it's run as a script. So this __main __ is the name of the scope in which top-level code executes. A module's name is set equal to main when read from the standard input, a script, or from an interactive prompt. So we're checking if name equals main, and if so, it will run that code, which is just if it's run as a script. So let me show you how that would be used. So we have this program here that defines the add function here, and then now we're testing the add function. But now if we want to use this module, this code here, we would have to comment out this test here. So instead, in the program, we'll say if name equals main. So now if we import this file, it's not going to add this, but if we run this file just as a program, it will run this add35. We've reached the end. You can learn about Python classes and objects in this other video. Leave a comment explaining how to use the parts of Python I missed, and I'll pin the most helpful comment.